Hello, everyone. Today we're going to take a look at some new ideas in terms of what are called imaginary numbers and complex numbers. So this idea that numbers can exist, but yet not really exist because they're imaginary. You're going to need your notes, something to write with, as well as a calculator today. So let me tell you a little bit of a story before we start writing our notes. Once upon a time, there's this man who sits down to solve a quadratic equation. And he looks at it and he says, hey, I can solve this. I can get the x by himself. I'm just going to go ahead and subtract 10, subtract 10. X squared equals negative 10. Then I'm going to square root, square root. Uh-oh. Plus or minus. He goes and he's trying to figure out how this whole square root negative number business works. In fact, if you were trying to calculate this in a calculator, it would give you an error message because there are no numbers in the real number system that when you square them give you negative values. So he does not like what he sees, this man, okay? He does not like it. In fact, he knows that every problem that's a quadratic that has an x squared in it like this is supposed to have two solutions. So how is it that some of them will end up having no solutions? He doesn't like that inconsistency. So what the man does is he comes up with a new number system. So his calculator, he didn't have calculators back then because it was a long time ago. His calculator can't even do it. So he invents a new sort of number system and new types of numbers. And so imaginary numbers were born. His name was Descartes, okay? He's a pretty famous mathematician. If you ever go on to take math classes in college, you may hear of him again. So Descartes, he's a Frenchman, and he comes up with this new type of number system. Most of our math world, or our works thus far, has really dealt with what are called the real numbers. Those are numbers that are rational. They can be written as fractions and ratios, and the ones that aren't rational are irrational. Those are like the pies of the world and the square roots of 2 and fractions and decimals and integers and whole numbers and 0 and natural numbers. See, all of these numbers are real. They exist. You can calculate with them. However, over here, if things are not real, like we're used to, then they become imaginary numbers or complex numbers. So this idea that there's this whole other number system that we haven't really talked about so far, that's what we're looking at today, the idea of an imaginary number. So his very first sort of presentation of this idea was this understanding that let's just make I equal to the square root of -1. And so you can go ahead and write this part in your notes. The idea of imaginary number, or the imaginary unit as it's called, I is going to equal the square root of -1. So he says from now on, every time I see a square root of -1, it's going to be I. And then so, if I were going to go ahead and square the I, and I square this side too, well then you can see that I squared would equal just a regular value of -1. The integer that we're used to. So these are the two big facts that you need to make sure are in your notes. Maybe put a bubble cloud around it or something so you can find it again. Because I equaling the square root of -1 and I squared equaling -1 is a pretty big deal. So how do we use I to rewrite square roots? Well, this idea that up until this point in your math career you've been putting no solutions, that's kind of out of the window now. Now things do have solutions. We can work with things that have square roots inside negative, or negatives inside square roots. So let's think about how that I thing can help us out. See, the square root of -25, that's the same thing as saying I have a square root of a -1 times a square root of 25. Because the -1 times the 25 would make -25. But now that we understand I, the whole square root of -1, this guy right here, that's an I. And then the square root of 25, well, that's just 5. So what we would say here is that this simplifies to become 5I. That's right, we'll leave an I in there. We're not solving for I, we're using I to rewrite something that was a negative square root. So let's take a look here at this next one. This is the square root of -6. That's the square root of -1 times the square root of +6. The square root of -1 is an I. The square root of 6 is something that cannot be square rooted and it cannot be broken apart. So we'll just leave that alone. So my final answer would be I square root of 6 You can also write the I after the square root sign, but sometimes that gets a little sketchy because it might look like it's underneath your square root. So most of the time those I's will be in front of that square root symbol. And now the third one here, the square root of negative 40. The square root of negative 40, let's think about it, is like the square root of negative 1 times square root of 40. The square root of negative 1 is the I. The square root of 40 actually can be broken apart into 4 times 10, square root of each, so it becomes 2 square root of 10. So if I was going to take a look at rewriting this with an I would say I'd have a 2 and an I out in front of the square root of 10. So 2i square roots of 10. The idea that the I comes out when you have a negative inside of a square root, that's the big idea. So let's take a look at a few other ones here. This is a square root of a negative 48. So I'll go ahead and rewrite that with the negative 1. That's going to become our I. And the positive 48. So this guy right here becomes the I. The square root of 48. 48 is the same thing as 16 times 3. The square root of 16 is 4. The square root of 3, I'm going to leave. And if you notice, this problem also had a 5 already in front of the square root sign, in front of that radical. I'm going to go ahead and bring him down here, plop him down with the rest of the things that are outside that radical sign. So this becomes 5 times I times 4. So it becomes 20I square root of 3. Okay, now let's look at this last one. Square root negative 18. Let's just do the top and then we'll go ahead and figure out the denominator. We'll work on the numerator, figure out the denominator. So square root of negative 18 is the square root of 1 times the square root of 18. But 18 can be broken apart into the square root of 9 and the square root of 2. So the top part of this fraction is going to become, there's an I for the square root of negative 1. The square root of 9 is a 3. And the square root of 2, I'm just going to leave. Okay. And then the bottom, there was just a 4. So square root of 4 is just 2. That's kind of nice. So if I was going to rewrite this in a better form, I'd say I have 3i square root of 2 over 2. And that would be my final simplified answer. So with all of this development of I and being able to rewrite negative answers underneath radical signs like they do, then this whole idea of you can operate with them. How do I simplify complex numbers? Those that are part real numbers, like part regular numbers like we're used to, like 6 or 7, and those that are part imaginary, so some that have I's in them. The good news is this idea of I representing something is not new. Variables represent numbers all the time. So we would still do things with them just like we would any other variable, an x, a y, whatever. If I see I outside 3 plus I, I'm going to go ahead and distribute. I times 3 is 3i. I times I is I squared. Now the only difference is things can represent other values. So this I squared, remember I squared, we wrote in the very first part of our notes, is the same thing as a negative 1. So 3i minus 1 would be what I really have here. And then when you write complex numbers where you have a real number, that's this negative 1, and one that's imaginary, one that has an I, when you rewrite those in complex number form, usually the real number part comes first. So I would rewrite this as negative 1 plus 3i. That would be my final simplified answer. And again, we can add, subtract, anything with i's, we can still do what we normally do, just like anything else, just like an x. It's just that remembering that I squared represents something. So here when I take these two, I'm supposed to add these two pieces together. So 3 plus 4 are the real number parts. So that's 7. And then the imaginary parts, negative 4i. Just adding like terms like we normally would do. One last one to take a look at would be this guy down here. Here we're supposed to multiply these two things times each other. So 2 things times 2 things, I'm going to have to do some distributing here. 3i times 4 is 12i. 3i times negative 5i becomes negative 15i squared. 6 times 4 is 24. And 6 times negative 5i is negative 30i. So when I take a look at what I have here, remembering now I squared represents something. It stands for negative 1. So this is like a negative 15 times a negative 1. That's like a positive 15. So 12i plus 15 plus 24 minus 30i. Now when you go to write these in complex number form, we're going to want our real numbers first. So here are my two real numbers, 15 and 24 make 39. And then my two imaginary numbers, 12i and negative 30i is negative 18i. So here's my final simplified answer. So this idea of getting used to I and recognizing when we're going to need him and how we're going to work with him when he's already there, that's what we want to look at starting next week. Okay. So thank you for taking good notes, and I will see you later.